All right. The last area we're going to look at right now is called factoring by grouping, or factor by grouping. And basically, if you've kind of noticed as we've gone along, right, we started out by just pulling out common terms, okay, and hopefully remember that's the first step always. So if you can find a common term, you pull that out. And then we moved into difference of two squares, and that was when you had only two terms, and you could find a perfect square minus a perfect square. And then we moved into trinomial squares, and those were when you had three terms, right? And you had a perfect square at the beginning and the end. And then the middle was, if you multiply them together, multiply them times 2. And then we did just regular factoring of trinomials. Okay, so we did that. And this is the last part we're going to look at. It's factoring by grouping. Okay, and before we really get into it, I want you to kind of look at this problem that I have written up there, and it's in your notes on page 15 as well. And if you look at it, if you think about your steps, okay, before you think about factoring by grouping, if you look at all the terms there, the first thing that you should be looking for, right, is a common factor. So if you look here at this problem, and you look through them all, we do have a common factor, right? Okay, they're all the numbers are divisible by 3, and they all have at least one x in it, so we can pull out an x also. Okay, well, if we pull out that 3x from the first term, we just gonna have to multiply it times x to the third, and that'll give us 3x to the fourth. To do the second one, we do it times positive 4, and we need 2 more x's, so x squared. To do the next one, we do times negative 2, and we need 1 more x. And to get the last term, we do it times negative 3, and we have all of our x's. So you're done. Okay. So that was factoring by grouping, right? You find a common term and you pull it out. Okay. Well, when you're talking about factoring by grouping, you're actually doing the same kind of thing. Okay. But if you look here, the problem that we have right below there, we have x cubed plus x squared plus 2x plus 2. Okay? And the first step is always to look for a common factor. Well, if you look at this problem, we don't have a common factor for all of them. So we're kind of out of luck with that one. It's not a difference of two squares. It's not a trinomial, so are we just out of luck or what? So we're not, though. We do this thing called factoring by grouping. And so what you do is you group your problem together in groups of 2, okay, or binomials. And so what I'm going to do is I'm just going to group this little part together right here, and then I'm going to group this part together right there. Okay, and what you're going to do is with each part, excuse me, with each part, you're going to find the common factor. Okay, so we have x cubed plus x squared. Well, if you look at that, those two right there have a common factor of x squared, right? They both have at least two x's in them. So if I pull out that x squared, I'm left with an x, and then I'm left with plus 1. Okay, and now if I look at the second part, and there should be a little plus in between here. Every time you do a common factoring by grouping, you should always put a little plus in between them. Okay. If we look at the second part, what we have in common is a 2. So you're going to pull out that 2, and when you pull out that 2, you're now left with what? X and plus 1. Okay? Now here's what I want to show you now. This is kind of a weird way to look at it for you guys. I'm going to move this up just a hair. There we go. Okay, but if you look at this, if you looked at this as two different terms, okay, you have an x squared times x plus 1 and a 2 times an x plus 1. Okay, if you notice here, what we have is we actually have in the two different terms an x plus 1 in common. So really, if you looked at this as two separate things, they both have an x plus 1 in common. And so what you could do is you could actually factor out that x plus 1. So we pull out the x plus 1 from both of them. Now if we pull out x plus 1 from this one, we're left with x squared. And then if we pull it out from this one, we're left with plus 2. Okay, and now we've factored by grouping. So we have the x plus 1 times both of those, and if you multiplied all that back together, you'd end up with the same answer. Okay, so what you're doing here, right, if you look at the steps again, you cut it into two different sections, and then you find the common term and pull it out. And then once you're done, you find, hopefully you end up with something that is common to both of the terms. Okay, and then you can factor that part out. Alright, let's do some more examples, and hopefully this will start to make a little bit of sense to you guys. Okay, so the next example, we're on page 16 now. We're about midway through, so we have 6. Oh, that's just a little light there, doesn't it? Okay, so we have 6x cubed minus 9x squared plus 4x minus 6. Okay, and now if you look at this, right, we don't have a common factor to everything, and it's obviously not something we can factor normally. So what we're going to do is we're going to group them. Okay, so we're going to group these together. And now we have two different parts that we could factor, right? We do have factors in common. So if we look at the 6x cubed minus 9x squared, we can both pull out here a 3, okay, because 6 and 9 have 3 in common, and they both have at least 2 x's or x squared. Okay, now to get back there, we have 2x to get there, and we have minus 3 to get there. Okay, then you have a plus, and then what's common here is a 2, and so to get back you have 2x, and you have minus 3. Okay, and now if you look, right, both of our terms have this 2x minus 3 in common. So we're going to factor those out. You get 2x minus 3 is going to be pulled out of them now. And so if I pull 2x out of minus 3 out of the first one, I'm left with 3x squared. And if I pull it out of the second one, I'm left with plus 2. And now I'm done. Okay, so it's pretty simple. What you're looking for here is you're hoping that when you factor this all out, that you have a term in common. Okay, so you want something that can be in common that you can pull out of both of them, and then you're left with your two binomials. All right, let's keep going. So the next one we have x cubed plus x squared plus x plus 1. Okay, again, nothing in common of all of them, so we're going to break them into chunks. Okay, and x cubed and x squared have x squared in common, and when you pull it out you have an x left over plus 1, and then you have plus, okay, well there's nothing in common here, but if you think about it, right, if we don't have to, we do have a little 1 that we could multiply by it, right, because 1 times that doesn't change anything, so we have a little 1 there. Okay, now we pull out our common factors, so our common factors are x plus 1. So x plus 1 times x squared plus 1. And there you go. We're all done. Okay? It's a pretty simple thing. We're going to do a couple more examples here that we can keep going, and then we're all done here. So we'll just keep on moving along. Okay, the next one, we have x to the third plus 2x squared minus x minus 2. Okay, so again, nothing in common in all of them, so let's break it into little parts. Okay, and I want to put the minus in the parenthesis there with it. Okay, so we're going to do, our factor here is x squared, then we have x plus 2, and then I'm just going to put a plus, okay, and I'm going to factor out, okay, right now I have negative x minus 2. Well, if I just do this, right, if I just copy this down, well, I don't have anything in common here. But if you notice, what we can do, okay, is we could actually, I'm going to copy down the first part really quick again. What you could do is you could actually factor out a negative 1. Okay, if I pull negative 1 out of that, it changes all my signs, right? So my negative x becomes positive x, and my negative 2 becomes positive 2. And look, now I have common, okay, common factors. So if I pull out my x plus 2, and then I'm left with x squared, and instead of writing plus -1, I'm just going to write -1. Okay? Now, hopefully you're paying a little bit of attention here, and you might have noticed something. Okay, darn it. It's never easy. It always has to go a little bit further, right? Okay, hopefully you noticed that we have a difference of 2 squares right there, right? X squared minus 1. So we're going to copy down our x plus 2, and then our x squared minus 1 breaks into x plus 1 and x minus 1. And now we're done with that problem. Okay, so don't forget, as you're going along, you still have to factor completely. So as you're moving down, you got to keep looking for all the extra stuff that we've already done before. Okay, so don't forget about all the other stuff. All right, we have a couple more examples still. Okay, so this time we have x squared y squared plus a y squared plus ab plus bx squared. Okay, well, this is a little ugly, but I think we could still do it. So let's break it into two parts. Every time I pull from the top up there, it brings down this little bar that doesn't help me very much. So here we go. So what do we have in common from the first two? We have y squared in common. So we're left with x squared plus a. Okay, and then in the second one, we have a b in common, right? So we're going to do plus b, and then we have a plus x squared. Well, they're not exactly alike, but they are alike, right? Because we have that commutative property. So we have y squared times x squared plus a plus b times x squared plus a, using the commutative property to flip those two around. And now we have two terms that are common. So we have x squared plus a times y squared plus b. Alright, there you go. Pretty simple. Okay. Now the last one, you can already see it says, the last one says that it cannot be factored, so you can see the answer already. But let's take a look at it anyway, just to make sure that that's correct. So we have x to the third plus x squared plus 2x minus 2. Okay, no common factor for all of them, so we're going to break it into its parts. Factor out our x squared out of the first one. We get x plus 1. And then plus, we factor out our 2, and we're left with x minus 1. Okay, well, that doesn't really work, right? We don't have a common factor in there, because x plus 1 and x minus 1, they can't become the same thing. So we're done right there. You're all done with it. You can't do anything with it. So you're all done. Alright, so hopefully after looking at all that, you kind of got a little sense of what's happening here. Go ahead and give the try these a try. You have a couple here at the bottom of page 16, and then I believe, yeah, you have two more at the top of page 17. So give those a shot and then come back. Alright, so let's look at the first try this. Okay, we don't have a common factor all the way across. They're not difference of two squares. They're not trinomial, so we're factoring. Okay, by grouping. Okay, so we're grouping those together. In common in the first two, we have 2 and we have x squared. So we're left with 4x plus 1. And then you have plus, and we have a 3 in common there. So that'd be 4x plus 1. Okay, there's our common factors. So 4x plus 1 times 2x squared plus 3. And we are done with that one. Okay? Alright, next one. We don't have anything in common again, so let's go ahead and do our common factors. So here we have 2x squared, and that leaves us with 2x minus 3. And then over here we have plus, and if we have negative 6x plus 9. I think what I'm going to do here, because I don't want the x to be negative, right? If I just pull out a regular 3, my x is going to be negative. What I'm going to do is I'm going to pull out a negative 3. And if I pull out negative 3, then my first term, right, to get back there, is now 2x, and my second term from negative 3 to positive 9 needs a negative 3. And look at, now I have my common terms. Okay, so factor out that negative 3. So I'm left with 2x minus 3 times the quantity 2x squared plus 3. Alright, that looks pretty good. Okay, let's keep going now. Okay, let's look at the next one. We have x cubed plus x squared minus x minus 1. So we'll break it again into the two parts. And x squared and x cubed, we have x squared in common. That leaves us with x plus 1. And then here again, so we have a bunch of negatives in there, so I'm going to factor out the negative. So I'm going to bring out negative 1, and that's going to switch these to x plus 1. Okay, and now I have common factors. So I have x plus 1 times x squared minus 1. Alright. Did I trick you? Did you get it? Did you see what we're looking for now? We have x squared minus 1, right? Okay, difference of two squares. So we should have x plus 1 and x minus 1. Okay, and really if you wanted to write this like completely correct, okay, the x plus 1 and x plus 1, you have two of them. So really, I'm running out of room here, you should do x plus 1 squared times x minus 1. Okay, and there you go. I'll take either answer though, so don't stress about it. Alright, and the last one, 3a minus 6b and 5a squared minus 10ab. So we factor a 3 out of this, you're left with a minus 2b, and then we factor out a 5 and an a, so we're left with a minus 2b. Factor out our a minus 2b, and you are left with 3 plus 5a. Alright, we're going to stop there. You have now learned all the different parts of factoring. Okay, so we'll the next parts now are just using all that we're doing and putting them into equations and stuff. So if you're not confident in any section that we've done so far, I suggest you go back and re-look over them and look over them and look over them and keep practicing and doing as much as you can, because this is super important as we go along. Alright, hope that's good enough for you.